this is 9th class physics, ICSE, Indian Certificate of Secondary Education. So in this, ఇప్పుడు మనం చూస్తే first chapter units and measurements. So measurements and experimentation. So what are measurements? So measurements అంటే ఏంటో చూద్దాం మనం ఇప్పుడు. Coming to this chapter of units and measurements. మెజర్మెంట్స్లో మనకి మీనింగ్ ఆఫ్ మెజర్మెంట్ ఏంటి? సో వీ హ్యావ్ టు నో ద మీనింగ్ ఆఫ్ మెజర్మెంట్. సో రిమెంబర్ వన్ థింగ్, when measurement is nothing but you have to have a standard unit, and with a known unit you are counting the unknown unit. Means for a known physical, with a known physical quantity you are calculating or measuring the unknown physical quantity. అది ఎలాగో ఒకసారి చూపిస్తాను మీకు. మెజర్మెంట్ is the process of comparison of a given physical quantity, comparison of a given physical quantity with the known standard quantity, with the known standard quantity of the same nature. You have a scale which you have known physical quantity, and you are taking the scale and you are measuring the table, you are measuring any other linear things for length, breadth. So all these things are called as measurements. So with a known standard quantity, scale is a known standard quantity, okay, and common balance is a known standard quantity, vernier calipers is a known standard quantity, screw gauge is a known standard quantity. With that you are comparing the given physical quantity, then we have to call it as a measurement. మన దగ్గర ఒక స్కేల్ ఉంది, ఆ స్కేల్తో మనం బెంచ్ని కొలవచ్చు. స్కేల్ అనేది మనకి ఎంత క్వాంటిటీ ఉందని మనకు తెలుసు, దాంతో మనం మిగతా వాటిని కానీ కొలిస్తే వాటినే మెజర్మెంట్ అంటాం. యూనిట్. సో యూనిట్స్ అంటే ఏంటి? సో వాట్ ఆర్ యూనిట్స్? యూనిట్స్ ఈజ్ నన్ అదర్ దాన్ is the quantity of a constant magnitude. Is a quantity of constant magnitude. సో ఫర్ ఎగ్జాంపుల్ 1 సెంటీమీటర్ అంటే కాన్స్టెంట్, అంతే ఉంటుంది డిస్టెన్స్. ఒక పాయింట్ నుంచి ఇంకో పాయింట్కి అంతే ఉంటుంది డిస్టెన్స్. కిలోమీటర్ అంటే అంతే ఉంటుంది, మీటర్ అంటే అంతే ఉంటుంది. సో వీటినే మనం యూనిట్స్ అంటాం. which is used to measure the magnitudes of other quantities of the same nature. రైట్, రిమెంబర్ దిస్. ఇందులో ఏంటంటే యూనిట్ అనేది ఒక కాన్స్టెంట్ మ్యాగ్నిట్యూడ్ అంటే నెంబర్తో డినోట్ చేస్తాం. సో ఇంటూ ఒక యూనిట్, 2 యూనిట్లు, 3 యూనిట్లు, ఇవన్నీ కాన్స్టెంట్ మ్యాగ్నిట్యూడ్ ఉంటాయి. ఖచ్చితంగా ఈ పాయింట్ నుంచి ఈ పాయింట్ దాకా ఇంతే లెంత్ ఉంటుంది. ఫర్ ఎగ్జాంపుల్ 1 సెంటీమీటర్ అంటే ఇప్పుడు ఈ పాయింట్ నుంచి ఈ పాయింట్కి 1 సెంటీమీటర్ అంటే ఇది 1 యూనిట్. దీన్ని 2 టైమ్స్ చేస్తే 2 సెంటీమీటర్స్, 3 టైమ్స్ చేస్తే 3 సెంటీమీటర్స్. ఓకేనా? సో ఇలా వాటి మ్యాగ్నిట్యూడ్ని పెంచుకుంటూ పోతుంది. యూనిట్స్ తోటి డినోట్ చేస్తాం అన్నమాట. సో లెంత్ని కానీ బ్రెత్ని కానీ వీ విల్ బీ డినోటింగ్ విత్ ద యూనిట్స్. సో magnitude along with units will tell us number of times the units is multiplying. ఎంత లెంత్ ఉంది, ఎంత బ్రెత్ ఉందని ఇలా కనుక్కుంటాం. ఇప్పుడు ఫిజికల్ క్వాంటిటీని తీసుకున్నారు మీరు, యు ఆర్ టేకెన్ ఏ ఫిజికల్ క్వాంటిటీ. న్యూమరికల్ వాల్యూ into units. Numerical value, for example, 7 units centimeters, 3 meters, 5 kgs. This kg is the known measuring the magnitude of other units. This is the constant magnitude. Kg is a constant magnitude, and we are measuring the magnitudes of other quantities. For example, you have taken a weight of 5 kg, which you already know it is 5 kg, and you are comparing the 5 kg with the other sugar or anything to measure how many kgs does the sugar have, how many kgs does any pulses or rice have. Means you have taken one known magnitude, constant magnitude, and you are measuring the other physical quantities with the same nature. Solids, so solids will be always measured with the solids only, likewise. So choice of unit, how you have to choose the unit. So should be convenient size. Should be of convenient size. Should be reproducible. Should remain same everywhere. For example, wherever you go, it has to be same. Should remain same everywhere. And next, should have fixed definition. Right, these are the choice of units. It should be convenient size, should be reproducible, should remain same everywhere, and should have a fixed definition. Right, so this is how we choose the units actually. Types of units. The units are of two types. Fundamental units and derived units. So what is this fundamental unit? A fundamental unit is that which is independent of any other unit. That which is independent of any other unit, or which can neither be changed nor be related. So it is independent unit. So you cannot replace with any other thing. There is no alternatives. Means unambiguity. Or for example, weight, it is kg or gram. Only these units will be referred. For example, liters. So for volume it is liters. Right, so which can be neither be changed. We can't change that unit, nor can be related to any other fundamental unit. So that which is independent of any other unit, or which can be neither be changed nor can be related. So we can't relate it to any other, and we cannot change that unit. Those units we call it as fundamental units. For example, for fundamental unit is, for example, unit for length. So unit for length, it is meter. For mass, it is kg. So for temperature, it is Kelvin, and for luminous intensity, it is candela, and for electric current, it is ampere. So remember, these are the things we call it as units. These units neither be changed nor be replaceable with any other fundamental unit. We cannot do it there. Unit is always a constant thing. For if you want to count the units, for mass you have to take kgs. For time you have to take seconds or hours, minutes, like that. For temperature it is Kelvin. For Kelvin you cannot use for time. Seconds you can't use for mass. That is what the thing. You can't interchange with the other units. So always units are constant things. The only thing they will be used to measure the unknown quantities of related same substance. Amount of substance, mole. Next type will be derived units, right? Coming to this category, derived units. So what is this derived units? This is very easy. If you know the standard units, fundamental units, then you can tell what is a derived unit. So actually these derived units are those which depend on fundamental units. Depend on fundamental units, which can be expressed in terms of fundamental units as well. Which can be expressed in terms of fundamental units. Example for this is unit of area, meter square. Unit of volume, meter cube. Unit of area is meter square. Unit of volume is meter cube. So unit of area is length and breadth, but unit of volume is length, breadth and height, right? So m square, m cube. So meter square and meter cube. Actually we are taking the fundamental units and we are measuring the area and volume. So this is dependent on the fundamental measurements or not, fundamental units. And these are actually these units we call it as a derived units. Now we'll see the next thing, system of units. Systems of units. Coming to the system of units, we have mainly three system of units. So remember the fundamental quantities in mechanics. There are three fundamental quantities in mechanics. There are three fundamental quantities in mechanics. First one, CGSU system. This is actually a French system. And next we have FPS system. This is actually British system. MKS system. This is metric system. Right? So CGS is French system, FPS is British system, MKS system is metric system. We'll see what are these systems actually. Okay, very first thing, and we have three basic things, that is length, mass and time. Remember, length, mass, time. Okay, we'll go to the, for what are the first thing for the unit of length. CGS system, otherwise we call it as SI system as well. So for this, in the SI system, for the unit of length, is meter, which is m. So we'll see what is a meter. Meter was originally defined in 1889. So in 1889, the meter was originally defined. So what is a meter? Very simple, the distance between two marks drawn on a platinum, iridium. So what is platinum iridium is, it is an alloy. So which is nearly with 90% of platinum and 10% of iridium. So we have 90% of the platinum and 10% of iridium. Rod kept at 0 degrees Celsius. So in the International Bureau of at Sivers near Paris. So the invention is first discovered in 1889, and it is nothing but the two marks drawn on platinum iridium. So platinum and iridium, which is 90% of platinum and 10% of iridium. So that rod, it kept at 0 degrees Celsius. Okay, even with the temperature also, the length will vary. So if the temperature increases, the rod will expand. If the temperature decreases, to minus, the rod will contract. So like this, particularly at 0 degrees Celsius, it is very, very important. So which is kept in International Bureau of Weight and Measures at Sivers near Paris. And again, in 1983, the meter was redefined. Remember, in 1983, the meter was redefined. Again, in terms of speed. Redefined in terms of speed of light. According to which, that is none other than 1 meter is the distance travelled by the light. 1 meter is the distance travelled by the light in 1 by 299,729,458 of a second in air or vacuum. So this we call it as distance, so meter. So again they redefined in 1983. So which is nearly after 100 years they redefined the meter with the speed of travelling of the light. Now So subunits of meter will be the subunits of meter. The subunits of meter are centimeters, millimeters, micrometers, and nanometer. Right? So these are the subunits of meter, especially meter. These are all for defining the length or measuring the length. How you will take this as 1 centimeter is equal to 10 to the power of minus 2 meter. That is 1 meter is equal to 100 centimeters. And next 1 millimeter is equal to 10 to the power of minus 3 meters. 1 micrometer is equal to 10 to the power of minus 6 meters. 1 nanometer is equal to 10 to the power of minus 9 meters. So how we are telling it as 1 meter, 1 centimeter is 10 to the power of minus 2 meter. So 1 meter is equal to 100 centimeters, which means 1 by 10th, 1 by 100th meter is equal to 1 centimeter. So if you convert this 1 by 10 square is equal to centimeter. So 10 minus 2 meters is equal to 1 centimeter. Like that you have to calculate for the other things also. For 1 millimeter it is 1 meter is equal to 1000 millimeters, which is 1 meter is equal to 1 by 10,000, 1 by 1000 meters. So if you try to calculate this, 1 meter is equal to 10 to the power of minus 3 meters. So excuse me for this. So what is 1 meter? 1 by 1000, 1 by 1000 part of the meter is 1 millimeter. So 1 by 10 cube meter is equal to 1 millimeter. So if you can bring it, 1 millimeter is equal to 10 to the power of minus 3 meters. That's how you get this minus 3, 10 to the power of minus 3 minus 2 likewise. Next we'll see multiple units of meter. Multiple units of meter. If you take kilometers, so 1 kilometer is equal to 1000 meters. So this is one multiple of meter, and the next is astronomical unit. So in astronomical unit, the distance between Earth and Sun. What is an astronomical unit? Is distance between Earth and Sun. 1 AU is equal to 1.496 into 10 to the power of 11 meters. Right? And okay, remember this, 1 AU, 1 astronomical unit is equal to 1 astronomical unit is equal to 1.496 into 10 to the power of 11. Next it is light year. So light year is nothing but distance travelled by light in 1 year. Distance travelled by light in 1 year. 1 LY, 1 light year is equal to 9.46 into 10 to the power of 15 meters. You have to remember these points as well. And next, D, parsec. So distance, what is parsec? Parsec is distance from where semi-major axis of orbit of Earth subtends an angle of 1 second. An angle of 1 second. So 1 parsec is equal to 3.26 LY, light years. 1 parsec is equal to 3.26 light years. 1 light year is equal to 9.46 into 10 to the power of 15 meters. Parsec is, so at which the earth will tilt. While earth is revolving around the sun, how much angle does the earth will tilt? So that is nothing but 1 parsec is equal to 3.26 light years. Next it is LR units. We call these units as LR units. So what is this LR units is? For measuring wavelength of light, size of nucleus, etc. This is very, very smaller. If you take 1 angstrom, 1 angstrom is equal to 10 to the power of minus 10 meters. That is 1 nanometer is equal to 10 angstroms. Right? 1 Fermi. This is 1 angstroms. 1 Fermi. 1 Fermi is equal to 10 to the power of minus 15 meters. Right? These are the things we have to remember for measuring the length. Let's see the unit for mass. The SI unit of mass is kilogram. Again, like the same definition, in 1889, 1 kilogram was defined as 1 kilogram was defined as the mass of cylindrical piece of platinum iridium alloy. One piece of platinum iridium alloy kept at International Bureau of Weights and Measures. International Bureau of Weights and Measures. At Sivers near Paris. This is the exact weight, accurate weight which is present in International Bureau of Weights and Measures. So the unit of mass is, now we will see the unit of mass. The unit of mass is, which is the very latest unit. So the unit of mass is Planck constant, which is the latest. Planck constant. Next, coming to subunits of kilogram. Subunits of kilogram. The subunits of kilogram are gram, B milligram. And multiples of kilogram. So the multiples of kilogram are A 1 quintal. 1 quintal is 100 kgs. And 1 metric ton. 1 metric ton is 1000 kgs. Again the same thing for 1 gram. 1 gram is equal to 10 to the power of minus 2 kgs. 1 milligram is equal to 10 to the power of minus 3 kgs. 10 to the power of minus 6 kgs. 10 to the power of minus 3 is for 1 gram. 10 to the power of minus 6 kgs is for milligram. 1 gram is 10 to the power of minus 3 kg. 1 milligram is 10 to the power of minus 6 kg. And the same thing 1 quintal is equal to 10 to the power of 2 kg. 1 milligram is equal to 10 to the power of 1 metric ton. 1 metric ton is equal to 10 to the power of 3 kg. 1 metric ton is 10 to the power of 3 kg. So coming to the next thing, non-metric unit of mass. Non-metric unit of mass. The non-metric unit of mass is 1 AMU or ARU is nothing but 1/12 of the mass of 1/12 of the mass of 1 carbon, 12 atoms, 1 carbon 12 atoms, that is equal to 1.66 into 10 to the power of minus 27 kg. Next, 1 solar mass. 1 solar mass is equal to mass of sun. Mass of sun is equal to 2 into 10 to the power of 30 kg. Next, units of time. So SI unit is second. We already know this. SI unit is second. A second is nothing but, a second is defined as 1 by 86 400th part of mean solar day. 1 second is defined as 1 by 86,400 part of mean solar day. That is, you can able to write it as 1 second is equal to 1 by 86,400 x 1 mean solar day. One second is none other than is the time travel of 9.196 631 770 vibrations of radiation corresponding to the transition between two hyperfine levels of the ground, two
2 hyperfine levels of the ground state of the cesium. That is 133 atoms. So 2 hyperfine levels of the ground state of the cesium, that is 133 atoms, cesium 133. Coming to the next thing, the smaller units of time. The smaller units of the time. Coming to the smaller units of the time is the common smaller unit. The common smaller units are of timer. Milliseconds. Microseconds. Nanoseconds. Where 1 millisecond is equal to 10 to the power of minus 3 second. 1 microsecond is equal to 10 to the power of minus 6 second. 1 nanosecond is equal to 10 to the power of 9 second. We have a thing called shake. 1 shake is equal to 10 to the power of 8 seconds. So this is what the smaller units of time. Coming to the next, the bigger units of time. So the bigger units of time are minute, hour, day, week, month, year, leap year, decade, century, millennium. Okay, so now let's see 1 minute. What is 1 minute? 1 minute is equal to 60 seconds. We all know 1 minute is 60 seconds. What is 1 hour? 1 hour is 60 minutes. And next, so 1 hour is equal to 60 minutes. That means 60 minutes into 60 seconds, that is equal to 3600 seconds will be 1 hour. 1 hour is 3600 seconds. What is 1 day? One day is none other than the time taken by the earth. The time taken by the earth to rotate once on its own axis is called a day. So that 1 day is divided into 24 hours. So 24 hours is equal to 1 day. That means 86,400 seconds is 1 day. And next, coming to lunar month. Lunar month. What is this lunar month? So what is lunar month is, according to the Western or Gregorian calendar. Western or Gregorian calendar, it is based on period of revolution of earth around the sun. revolution of Earth around the Sun. So this is, we call it as lunar month, based on the revolution of Earth around the Sun. So based on that, we'll calculate the lunar month. And next 1 month. So months are nothing but, according to the Western and Gregorian calendar, we have totally 12 months, and 31 days will be there for January, March, May, July, August, October, December, of 31 days, and 28 days will be there for February. If it is 29 days, then it will become a leap year. Months we have 30 days, 31 days, 28 days, right? 30 days are none other than April, June, September, November, and 31 days is January, March, May, July, August, October, December, and 28 days is February. If it is 29 days, it will become a leap year. And next, coming to 1 year. What is 1 year? 1 year is defined as time that Earth completes. One revolution around the Sun. One whole revolution around the Sun. The period of revolution of Earth around the Sun is, so 1 year is equal to nearly 365.256 days. Right? Next, 1 decade is equal to 10 years. 1 century is equal to 100 years. So that it is 100 into 1 century is equal to 1 century is equal to 3.16 into 10 to the power of 9 seconds. That is 1 century. 1 millennium is equal to 1000 years. We have finished 2 millenniums. So 1 millennium is equal to 3.16 into 10 to the power of 10 seconds. Right? We already know that 1 day is equal to 86,400 seconds. So 1 year is equal to 86,400 into 365 days. That it is nearly 315,36,000 seconds. This is 1 year. And next it is guidelines to write the units. Guidelines to write the units. What are the guidelines to be followed? So the symbol for a unit which is not derived from a scientist name. So if it is not from a scientist name, there are some units which is derived from a scientist name, written as small letter. For example, meter. Meter is not a scientist name. That is M. Right? Kilogram. Kg. And so on. Assume that, for example, if it is the symbol of unit which is named after a scientist name, the first letter of his name has to be in capital. For example, if the symbol is after the scientist name, they named after the scientist, then it is written with the first letter of the unit is capital. For example, N for Newton, J for joule, W for watt, PA for Pascal, HZ for heads, C for Colombo, column, V for volt. So these are the scientist name actually. That's why we are writing with a capital letter to denote a sort of respect. Next, the full name of the unit. The full name of the unit. So irrespective of the fact whether it is named after a scientist or not, it always written in a lower case. Okay, so you always have to return the entire name of the unit. The entire name of the unit. Unit we have to write, if it is a scientist name, capital letter, and if it is not from the scientist name, the symbol has to be in small letter based for the symbols. The full name of the unit has to be written. Full name of the unit has to be written, whether it is name of scientist or not the name of scientist. Okay, so surely you have to written in lower case. So for example, it is not kilogram. This is wrong. Kilogram. This is right. Not meter. Wrong. Meter. Meter. Wrong. Meter. Right. For example, Newton. Right. Newton. Wrong. And next, final rule. A compound unit is formed by the multiplication of two or more units. Okay, so we have the unit called compound unit, we call it as, which is by the multiplication of two or more units, is written after putting a dot. Okay, putting a dot, cross, or leaving a space between the symbols. Leaving a space between the symbols. For example, n dot m or n into m or nm. So this is the way to write the compound units. Yes, these are the things, the part 1 of units and measurements. Okay, so this is very helpful for all the classes. The units and measurements is the first chapter for many of the physics classes. So thank you very much. Please do subscribe to my channel for more physics videos also. Thank you very much. Bye bye.